Hello students, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning types of faults in distributed systems. Now, before jumping to types of faults, let us first understand what is fault tolerance. What are the systems, which systems are called as fault tolerant systems? So one of the characteristics of distributed systems is partial failure, that it should sustain partial failure. So let us consider this scenario wherein there are different types of components that are present into the distributed systems. Now they are working as a whole. Now let's say one of the component is not working. So which means that it is a partial failure because all other components, rest components are working fine. So even if one of the component is failing, it is still able to perform its task and it is still able to sustain this partial failure. So one of the main goal while designing distributed system is to construct the system in such a way that it can automatically recover from partial failures without seriously affecting the overall performance. In a layman's language, so even if there are faults that are there into the system, that particular component will not work, but then the other parts will take over that component and it will run the distributed systems without even knowing the user that one of its part has been failed. So a distributed system should be fault tolerant and it should be able to continue its functioning in the presence of faults. However, yes, it will not work at its par, but then it will not come at halt as well. It will continue its execution, but obviously at a lower performance rate. So fault tolerance is related to dependability. Now what is dependability? So when we talk about dependability has four terms into it. Let us see each one by one. Availability. Availability is defined as the property that a system is ready to be used immediately. So at any time, at any given point of time, the system should be available to the user. That is 24/7 and 365 days. So at any given point of time, the system should be available for the users to work on it. Then reliability. Reliability refers to the property that a system can run continuously without failure. So see, these are the various computers that are connected into a network, and even if one of them is failing, the all others can take over, or this particular computer's load is transferred to some other computers and the system will work. It will not come to an halt. So in single point of contact failure or in single point of failure, what happens is that if one system will fail, the entire system comes to a fault. But in distributed systems, it is a reliable system wherein if one of the, or let's say this is a partial failure, in case of partial failure, its load will be transferred to some other computers in the network and the system will be up and running continuously. So the third one is safety. Safety refers to the situation that when a system temporarily fails to operate correctly, nothing catastrophic happens. So let us consider one example wherein you are going into an aeroplane and the pilots in the aeroplane and the base station employees are communicating with each other as there are no traffic signals in the air. There is a strong communication that takes place between the base station and the pilots. So the base station guides the pilots that you have to take after 2 seconds. Let's say you have to take 90 degrees turn. Now if this communication is lagging, or let's say this communication channel itself fails, so it is a huge danger, or it is a catastrophic failure, because it will lead to damage to the lives of the people who are traveling in the aeroplane. So when we say it should the system should ensure safety, which means even if a temporary failure in the system may not lead to huge catastrophic errors, or maybe it should not lead to damage to the life of the people. So for example, here I have mentioned that many process control systems, such as those used for controlling nuclear power plants, or sending people into space are required to provide a high degree of safety. And the last point is maintainability. So what is maintainability? So yes, even if the system fails, it should be repaired. So finally, maintainability refers to how easily a failed system can be repaired. So these are the four parameters when we talk about dependability, and a fault tolerant system should have all these four parameters. Then only these distributed systems are called as dependable systems. Then I would like to come to distinguish, I want to distinguish between this availability and reliability. What is availability? So see, as we have told that the system should be available 24/7, 365 days to the user. So if I say that my system goes down for 1 milliseconds per hour, it has an availability of more than 99.99%, but it is unreliable because for that 1 millisecond, the system was not available. Right? So it is unreliable. Availability is high, but then it is not reliable because even in that 1 millisecond, it could lead to huge damage to the life of the people. Then reliability, we can say that a system that never crashes, but it is shut down for a week once every year, is 100% reliable, but only 98% available. So the system is never crashing, but we are shutting it down for 1 week. So the system is 100% reliable for sure, because whenever it is running, it is not crashing down, and it is there for the users to use. But then for 1 week, it is not available to the users. So in that case, it is not available. Availability is 98%. Now, some more terms related to fault tolerance. A fail. What do you mean by fail? So whenever system is not able to keep up to its promises, then the system is failed. So if a distributed system is designed to provide its user with let's say a number of services, and the system is failing to meet those services, let's say out of 10, distributed system is failing in accomplishing 2 services. So in that case, the system is said to be failed. Then the next definition is error. So if you just look at this diagram, I would like you to just understand this is a programmer. Maybe he has performed some syntactical error, maybe he has not put in this parenthesis properly at its proper place, and because of that a fault has been generated in its code. Now when this fault is generated in the code, it leads to the failure of that particular operation. So the programmer has created an error. Due to this error, a fault occurred in the software, and due to this fault, the system was failed. The same thing I have depicted in the definitions. So error is a part of the system state that may lead to the failure. So example is sending data packets across the network. Then fault is the cause of an error. So let's say if this particular fault occurred, which is the cause that what was the cause? The cause was this error, right? So error may lead to the fault, and fault leads to the failure of the system. In the fault tolerant, the system can tolerate faults that continue to operate normally. So a system should be a fault tolerant system. So even if there are faults, it should continue its operation normally, yes, but not at that actual good quality. The performance or the quality of the output will be somewhat of lower quality, but then the system will not come to a halt. So these faults are generally classified as transient fault, intermittent fault, and permanent fault. So let us see these faults one by one. So these transient faults occur once and then disappear. Okay. So let's say this is a data structure, and let's say this is a master, and these are the clients that are connected to this master, and the server is not able to send responses to the client due to, let's say, network issues and infrastructure issues. So response was not able to send to the clients. Now what happens after some time, this network issue gets resolved, even this infrastructure issue get resolved, and now the master was able to send the response successfully. Now the fault was removed. So by just retransmitting, or maybe for just it went off and it came for only once and then it disappeared. And the second one is intermittent fault. So if you're in this picture, if you are able to see, these are the loose connections that are there. So in intermittent, the normal English meaning is it is appearing, then disappearing, and then reappearing. So maybe due to loose connection, the power is coming, then it is going, and due to this loose connection, some packets are lost in the transmission. So a loose contact on a connector will often cause an intermittent fault. If I press that connection, it will give supply to the computer. So that is intermittent fault. And the last one is permanent faults. It appears and it persists until repaired. So here if you see, these are the software bugs. Then due to this burnt out chips, and probably there are disk head crash. These are some examples that are there, and these are the causes of permanent faults, and it will persist. Persist means it will remain intact unless and until that particular part or that particular error is repaired. So the fault is persistent. It continues to exist until the faulty component is repaired or replaced. So these are the types of faults in distributed systems. I hope you have understood the concept, and thank you for watching the video. Please do like, share and subscribe to the channel. Thank you everyone.